All right, let's talk about derivatives. You've probably gotten the hang of how they work with addition and subtraction. That's pretty straightforward. But what happens when you need to differentiate functions that are multiplied or divided? Well, that's where things get interesting, and it's where two of the most powerful tools in calculus come into play, the product rule and the quotient rule. Today, we're going to master them.
So, here's the game plan. We'll kick things off by looking at a very common trap that trips a lot of people up. Then, we'll introduce the two essential rules you need to avoid it. After that, we'll get our hands dirty and walk through a clear example for each rule, step by step. And finally, we'll wrap it all up with the key takeaways to make sure this stuff really sticks.
Okay, first things first. Before we even learn the right way to handle multiplication and division, we have to talk about the wrong way. There's a huge, tempting mistake that almost everyone makes at first, so let's get it out in the open and tackle it head-on.
Look, with addition, life is simple. The derivative of a sum is just the sum of the derivatives. You just go term by term. It feels, well, logical. But, and I cannot stress this enough, that logic totally falls apart with multiplication. It is so tempting to just multiply the derivatives, but it does not work. It's a fundamental misunderstanding of how these rates of change interact, and it will give you the wrong answer every single time.
So if that simple, tempting shortcut is a trap, what's the right way to do it? Well, this is where we need to add two brand new, absolutely essential rules to our calculus toolkit.
First up, for when you're multiplying two functions, we have the product rule. The formula itself is f prime g plus fg prime. But honestly, the easiest way to burn this into your brain is with a little mnemonic. Left d right plus right d left. It's catchy and it perfectly tells you what to do. Take the derivative of the left piece and multiply it by the right piece, then add the original left piece multiplied by the derivative of the right. Simple as that.
And for division, we've got the quotient rule. Now, I know this one looks a bit more intimidating at first glance, but trust me, it has an even better mnemonic. If you think of the function on top as high and the one on the bottom as low, the derivative is low d high minus high d low, all over low low. That little rhyme is your secret weapon to getting this right every single time.
Okay, seeing the formulas is one thing, but calculus is not a spectator sport. The real learning happens when we actually put these rules to work. So let's break down a product rule example together and you'll see it's not so bad.
All right, here's our problem. We need to find the derivative of y equals the quantity 3x squared minus 1 times the quantity x plus 2. See that? We've got one function being multiplied by another. This is a perfect job for the product rule.
Now here's a pro tip. The best way to start these problems is to get organized. Seriously, break it down into its component parts. So as you can see here, we've picked out our left function, f of x, which is 3x squared minus 1. Its derivative? Easy, that's 6x. Our right function, g of x, is x plus 2, and its derivative is just 1. Laying it out like this makes the next step a piece of cake.
With all our pieces identified, we can just plug them straight into our product rule formula, f prime g plus f prime g, or, as we like to say, left d right plus right d left. That gives us 6x times x plus 2 plus 3x squared minus 1 times 1. And guess what? The calculus part is officially done. Everything from here on out is just algebra.
So let's clean it up. We distribute the 6x to get 6x squared plus 12x. Then we add the 3x squared minus 1. Combine our like terms, and there we have it. Our final simplified derivative is 9x squared plus 12x minus 1. Not too bad, right?
Awesome. Product rule is in the back. Now let's switch gears and give the quotient rule the exact same treatment. We're going to tackle a division problem with that same clear, methodical process.
Here's our next challenge. Find the derivative of the function x squared plus 2 divided by x minus 1. We've got a clear high function on top and a low function on the bottom. This has quotient rule written all over it. And just like we did before, what's our first move? You got it. We get organized. Our high function, the numerator, is x squared plus 2, and its derivative is a nice simple 2x. Our low function, the denominator, is x minus 1, and its derivative is just 1. Getting this set up right is half the battle.
Okay, let's walk through this process. Step 1 is all about applying the formula low di minus high d low all over low low. We just plug in the parts we identified. Now, be super careful with that minus sign in the middle. The order really matters here. For step 2, we just carefully simplify that numerator, distributing and watching our signs.
And finally, in step 3, we combine the like terms up top to get our final answer, x squared minus 2x minus 2 all over x minus 1 squared.
All right, let's zoom back out and make sure this all sinks in. We've covered a lot, but these two rules are so fundamental. We want to make sure they're locked and loaded in your calculus toolkit for good.
So here's the bottom line. From now on, when you see two functions multiplied, your brain should immediately scream product rule, left d right plus right d left. And when you see one function divided by another, that's your cue for the quotient rule, low d high minus high d low over low low. Those little rhymes are more than just tricks, they're your guide. They'll get you to the right formula every single time.
You know, mastering these two rules is about so much more than just solving a new type of problem. It's like you've just been given a key that unlocks a whole new tier of much more complex functions, the kinds of functions that actually model things in the real world, in physics, economics, and engineering. So the real question isn't just about what you learned today, but about what new, more challenging problems you can go out and solve tomorrow.